Hi, my name is Matt Sellen. I'm a physics professor at the University of Illinois. My colleagues and I developed this IOLab system, and I'm going to tell you how we are using it to change the way we do intro labs at the University of Illinois. We have a bit of a history with creating technologies to enable the proper pedagogies to be used in large classes, starting with iClicker some years ago, Flippit Physics, and now IOLab. Our motivation for our large classes is to have our students learn in the most efficient way possible. We, in fact, are changing our labs to focus on scientific skills rather than on concepts. And so we want students to learn critical thinking. We want them to design experiments. We want them to understand assumptions and uncertainties. And we want them to become confident in their skills. That is the goal of our labs. The catalyst then for this new way of doing our labs is the IOLab device. The important thing about it is that it's affordable, so the students can have one each, and it has a lot of sensors in it, so that means that they can use the same tool and get familiar with it and use it for 2 semesters. So the elements of our reformed labs are basically this. Each student has an IOLab device. They buy it at the bookstore at the U of I. They do a pre-lab activity before every lab they do in class. So in their dorm rooms, before their lab, they'll have some activity to do where they have to think about what they're going to do in class, think about the physics a little bit, think about the tools they're going to use, the sensors they're going to use, share the data with us. Then when they show up in the classroom, they are given very open-ended activities that involve them designing an experiment to make some measurement or test some hypothesis. And then they write a lab report as a group and turn that in at the end of the 2-hour period. This research is being supported by the National Science Foundation, by the way. So we have developed quite a lot of content, 20 labs in total for both the life science mechanics and life science E&M classes. This is currently in use by 600 students per semester here at the University of Illinois. Soon, next year, we're going to roll it out for our engineering sequence also, and it'll be used by about 2,500 students per semester. If you want to see this content, which is very similar for both groups of students, just email me, matts@illinois.edu. I'll set you up with the materials in Flippit Physics so you can view the way we do things. And I'll just take a couple of minutes right now really quickly to show you what you will see if you email me and I get you set up. And so let's go here, bring up a web browser. Here we go. Okay, and so like I said, there's 2 classes that we have created. There is this mechanics class and there's an E&M class. They both look very similar. There's 10 labs in each. The first, the pre-labs are shown here in the central part, so that is what students do at home. So the first pre-lab is getting the software running on their computer. Each student uses their own laptop for this stuff. And then the labs in mechanics look the way you see it right here. Over on the right-hand side, you can see the materials that the students print out or look at in class to help them do. So for example, if you look at lab 4 in the pre-lab, what the students do is measure at home in their dorm rooms, the acceleration when they push their IOLab device and it slides on a surface like their desk. And then their lab activities, you can see right here for that week, is to measure the coefficient of kinetic friction between their IOLab device and the surface of the desk that they have in their lab room. So we also have materials for the second semester. Again, the format is the same. The students do pre-lab assignments followed by in-class. So for example, the pre-lab assignment for lab 2 in this one has them measuring light. So the pre-lab has them practicing using the light sensor. Here it is. And so they see a little video on how to use a light sensor, and then they make some measurements and answer some questions. And then when they come into class, they're tasked with the job of measuring the brightness of a little light bulb as a function of voltage across the light bulb. So here's their 1 page of instructions. And also every week we give students a rubric, so they know exactly how they're going to be graded. So they're not graded on getting the right answer, they're graded on their thinking, their communication, their clarity of explanation of what they're doing, their understanding of uncertainties, and so on. Okay, so then to finish up, different universities, of course, will use different approaches. So I can show you the material that we developed at the University of Illinois, and colleagues at other universities are approaching things slightly differently. All of these things are valid and great ways of doing it, and I can probably tell you a little about those as well. But if you want more information, feel free to email me anytime you want.